Lesson 8.4 is about special right triangles. The two special right triangles that we're going to learn about are the 45-45-90 right triangle and the 30-60-90 right triangle. And those refer to the angle measures. We see the 45-45-90, the shape of it, it's an isosceles right triangle. And the 30-60-90, we see that it has opposite the smaller angle of 30 degrees, has a shorter leg and a longer leg opposite the 60-degree angle, and has a particular shape itself. Now there's some set relationships on the leg lengths of these and the hypotenuse length relative to the legs of these right triangles that you need to memorize. Okay, first, the 45-45-90 right triangle. We call the two sides, the non-hypotenuse sides, the legs of this, and they're both the same length. Hence, that's why we have the 45-degree angles in each of the two corners. So those are both 45s, and we have the 90-degree angle in the hypotenuse. So it turns out that whatever one leg length is, we'll call that x, then the other leg length is the same, is x, and that the hypotenuse is always x times the square root of 2. Okay, so we'll do a few examples of if we know x, or if we know what the hypotenuse length is, how to find the other sides. So in this first example, let's just say we know that this is a 45-45-90 right triangle, because we can see that one of the acute angles is 45, so that we know that the other one is also 45 degrees. And we see that one of the legs has a length of 5. So we know that the other length also has a leg is a length of 5, and the hypotenuse is the leg length times the square root of 2. So in this case, 5 root 2. Now let's do a second example. Let's say that all we know is that the hypotenuse is 10, and we have to get back to the leg length. So we know if we take the leg length and we multiply by the square root of 2 to find the hypotenuse length, then to go the other direction, we have to divide the hypotenuse length by the square root of 2 to get the leg length. So what I have to do is take 10 and divide it by the square root of 2. So we know that we can't leave that radical 2 in the denominator. So to rationalize the denominator of this fraction, we multiply it by 1 in the form of root 2 over root 2. And then in the denominator, I have the square root of 2 over times the square root of 2, which is a rational 2. And in the numerator, I have a 10 root 2. Okay, and now this is going to simplify to 10 divided by 2 times root 2, or 5 root 2. Okay, so there is actually a shortcut for how to determine that. It turns out that to divide by the square root of 2, you simply divide by 2 and multiply by the square root of 2. So to restate that, in order to take this hypotenuse length of 10 and divide it by root 2, we take the 10, divide it by 2 to get a 5, and then multiply that by root 2 to get a 5 root 2. And we know then, of course, that this other leg is also 5 root 2 in length. So that's the leg length relationship for 45-45-90s. Next, let's look at 30-60-90s. So the 30-60-90 special right triangle, we opposite the 30 degree, the smaller angle, we have the shorter leg, and opposite the longer, or the bigger angle, the 60-degree angle, we have the longer leg. Okay, so I refer to the legs as short and long, and then there's the hypotenuse. So it turns out that if we start with short leg, let's let x represent the length of the short leg opposite the 30-degree angle. It turns out that the hypotenuse is always exactly double that. It's twice the length of the short leg. So that would be 2x in this case. And then long leg is always short leg times the square root of 3. So x root 3. Okay, so let's look at some examples where we know one of the three leg lengths, or one of the three side lengths of a 30-60-90 right triangle, and how we would get the others. All right, in this first scenario, let's say we know the short leg length. Opposite the 30-degree angle, the length of the leg is 5. Well, then we know that the hypotenuse length will be 2 times 5, or 10 long. And the long leg length will be 5 times the square root of 3, or 5 root 3 long. Okay, so that was easy. Okay, in the second scenario, let's say that we know the long leg. So we know that opposite the bigger angle, the 60-degree acute angle, the length is 6 of that leg. So we always use the short leg as the reference point. In order to get to the hypotenuse, first you find the short leg, and then you could find the hypotenuse. So to get the short leg, because we had to multiply by the root 3 here to get from short leg to long leg, we do the reverse. We divide by root 3 to get back to the short leg. So if I take 6 divided by root 3, and we know we can't leave that root 3 in the denominator, so we rationalize it by multiplying by 1 in the form of root 3 over root 3. We get a rational 3 in the denominator and a 6 root 3. And then the 6 divides by the 3 to get a 2. So we get 2 root 3 as the length of the short leg. Okay, so the shortcut to do that is to divide the long leg length of 6 by 3 and multiply by root 3. So I just take 6 divided by 3 is 2 times root 3 gets me to the short leg of 2 root 3. Then, of course, to get to the hypotenuse, I know it's twice the length of the short leg, so I take 2 times the 2 root 3 to get the hypotenuse length. So the hypotenuse is 4 root 3. Okay, so that's the special relationship and how to find short leg and hypotenuse when you know long leg. So then there's one more scenario left. So the last scenario is, what if you know the hypotenuse length but you don't know the leg lengths? So again, we're going to always find short leg first, use that as a reference, and then from short leg we can work our way around to long leg. So to get the short leg, I take the hypotenuse and I divide it by 2. So it's going to be 7 halves, or 3 1/2. It's easiest just to leave it in a rational form. And then to get to long leg from short leg, I simply multiply by the square root of 3. So I get 7 halves times the square root of 3, or I can write that simply as 7 root 3 all over 2. And that's it for special right triangles.